Hi, it's Mr. Benson here with a short video on circuit analysis. Now this is an important part of Year 12 physics. It's a key skill that you'll need in a couple of areas where if you can't do circuit analysis reasonably well, it'll cause you some problems. Now I'm going to work through an example. This is something that is a bit harder than what you'd expect to find in a Year 12 exam, where they tend to only have two resistors in parallel and then one resistor in series. So you see in this one we've got a resistor in series at the top here, the 12 ohm resistor, and then we've got resistors in parallel underneath it, but this is a little trickier because we've got these two in series on the right hand side. But as long as we follow the steps properly, it's still going to work out. Now what we need to do. Now this is pretty typical of physics questions, where you, at each step of the question, you think about the information that you have and what you can calculate. Now the only thing you can do at the start is calculate the total resistance for the circuit. Once you've done that, you then have another piece of information, and so you can calculate something else. Once you've got the total resistance, you can calculate the total circuit current. Once you've got the total circuit current, you can start to calculate the voltage drop around the circuit. And then we can calculate the current in parallel sections. And so at each step we're getting more and more detailed in our analysis of the circuit until we can figure out what's happening in every single part of it. So let's have a look back at our diagram again. So we're going to think about how our resistors combine. So let's do that first. I'm going to jump around between the slides a bit just because I'm going to run out of room otherwise. Now the first thing that we've got is on the right hand side we've got actually I probably can't do that. We've got two resistors here, so we've got a 6 ohm resistor and a 4 ohm resistor. Now they are in series, so they're just going to add together. So R series is just going to equal 6 plus 4, which equals 10 ohms. Then to find the parallel part, now this is where you remember, for doing parallel circuits, it's 1 over R total equals 1 over R1 plus 1 over R2 and all that kind of stuff. Now that's mathematically exactly what you're doing, but that's not a very nice way to calculate it, because working with fractions is something that can be difficult, and people often forget to actually do the last step of getting the reciprocal in order to get the RT on the top line. So I suggest that when you're doing this you use your calculator, and I'll write on the screen roughly what you need to do. So we figured out that on the right hand side of our equation here, so on this side this adds up to 10 ohms, and over here, right hand side of our equation, sorry, of our parallel section, this is 10 ohms, and over here this is 8 ohms. So those are the two resistors we need to combine in parallel. Now the best way to do it is to use your calculator and type it in very much like this. So there's an x to the -1 button on your FX82 calculators, and you need to have a scientific calculator like that to take into your exams. So what I would type on my calculator is left bracket 10, then the x to the -1 button, plus 8, x to the -1 button, bracket x to the -1 button, and then I'd hit the equals. And what I get in this case is I get 4.4 ohms, or 4.44 ohms. When you're doing calculations like this, do it to say 2 or 3 decimal places. You're going to round it off later to 1 or 2 significant figures. So if you're doing it to an extra couple of digits, then your answer won't have any rounding errors in it. Okay, so we've got our parallel part of the circuit now. Now the total for the circuit is just going to be this parallel part that we've just figured out, which is so 4.4 ohms is the resistance for this whole bottom part of the circuit now. So the total resistance for the circuit will be that plus 12. So it's going to be 12 plus 4.44. So we have a total resistance of 16.4 ohms. Then the next thing we can calculate, which I haven't given a page of its own on my slides because it's so easy, is we can work out I for the circuit, and that is just V for the circuit over the resistance for the circuit. Now if we look back at our diagram, we had 24 volts, so it's 24 over 16.4, and we get 1.46 amps. So we've just done the first two parts of the first two steps. Now this would get you a lot of the marks in a question, but you need to be able to go on further to really get the rest of the marks. So calculating the voltage drop around the circuit. Now what this means is we're thinking about how the voltage drops from here, where it is plus 24, around to here where it's at 0 volts. So as we're going around the circuit, our potential energy is being used up to actually move the current, and so we can figure out how it's going to drop from this point here where it's still plus 24. It's going to drop down some amount between here and here, and then it will drop down to 0 volts over this side. Now actually, just before I do that, I'll just remind you as well that in this example we were looking for the total circuit current, so I1 through this first ammeter. So we've actually figured out one of those answers already. So I would just make it clear that this was I1 as one of my answers. Okay, so when we're going on to calculating potential drop, again we've got to think about what we know and what we can calculate. Now we know the current for the circuit, and then when we look back at the circuit, well, I know that all that current is flowing through my 12 ohm resistor. I know the resistance of that resistor, so what do I know? I know I equals 1.46 amps. I know for that resistor R12 is 12 ohms, which means that I can calculate the voltage drop across that 12 ohm resistor using V equals IR. So again, Ohm's law being a very important equation. So in any case, look at what you know. If you know I and R, you can calculate V, and so on. So in this case, I can work out 1.46 times 12, and I can find that my voltage drops by 17.5 volts across that 12 ohm resistor. So having a look back here, what that would mean is that if I had a voltmeter in my circuit here, that would equal 17.5 volts. Now we know that we've got 24 volts for the whole circuit, which means that we are therefore going to have between here and here the difference between those two numbers. So we're going to have 6.5 volts from there to there. Now there are actually several ways you could work this out. Now the way I chose to work it out is I worked out the voltage drop across the 12 ohm resistor, and then I subtracted it from the total voltage to get the remaining voltage. We could have equally used the resistance from the parallel part of the circuit, where we know that R parallel was 4.44 ohms. Now the current going through the 12 ohm resistor is the same as the current going through the whole of that parallel circuit. We don't know how it's splitting up yet, but we know that all of that 1.46 amps is flowing down these two branches of the circuit, some of it down this side and some of it down the right hand side. So we could do the same calculation, but just using the different resistors. So V for the parallel part is going to be 1.46 amps times 4.44 ohms, and what I get there is I get 6.5 volts. So you can see that either way you do it, you get the same answer. These two values add up to 24. So now we know something else, and that means we can calculate something else. So when we look back at our circuit, we now know that it's 6.5 volts from here to here. It means we can start to calculate other values. Now we want to know the current through the 8 ohm resistor. Now one important thing to remember, in a parallel circuit, the voltage is the same across all the parallel sections. So the voltage across the 8 ohm resistor is 6.5 volts. The voltage across the 6 ohm down, and the 4 ohm together is 6.5 volts. First thing we'll work out is the 8 ohm resistor, because that's nice and easy. So I through the 8 ohm resistor, so it's just V over R. Now this is 6.5 volts divided by 8 ohms, and we get 0.81 amps. Now the next thing I want to find is I want to find the voltage across the 6 ohm resistor. Now I can only find the voltage across the 6 ohm resistor if I know the current through the 6 ohm resistor. So two ways I could do this. I already know that there's 0.81 amps going through the 8 ohm resistor, so that in fact was my answer for I2. Now what that means is that the balance of the current, the balance of that 1.46 amps is going to be flowing through the other side. So that's going to be about 0.65 of an amp flowing through this side. So I could actually calculate my potential drop from there. I could also have done the I could do this calculation here, where I, for the 10 ohms, which is the 6 and 4 together, again is just V over R, it's 6.5 over 10, which equals 0.65 amps. So again, you can see that either way you do it, it gives you the answer, gives you a correct answer. So then the last thing I want to find here is the voltage through the 6 ohm resistor. And I know now that the current through the 6 ohm resistor is 0.65 amps. Multiply that by 6 ohms and I get 3.9 volts. So hopefully that's helpful. You just need to follow the steps that I've described. So finding the total resistance, calculating the current for the whole circuit, then you're able to calculate voltage drops around the circuit, and then you can calculate current in parallel sections, and if need be you can calculate voltage drops in parallel sections, although you're not likely to come across examples as complicated as this. I hope that helps. Please email me if you have any questions.